Welcome back, Mindsetters, to the Maths Show for Grade 10s today. Grade 10s, I hope you've been having such a great time. We've had some very nice, interesting sections. So just make sure that you have jotted down this question, because it's very nice for you to go through the question later when your mind is, nice and calm and you can practice it and everything else. Keep writing your notes as well. I mean, they will help you later on, guys, I promise you. Over to you, Dina.
Thanks, Katlego. I'm hoping that some of you by now would have really gotten that answer to the challenge, the first challenge question that we posted at the beginning of the show. So let's quickly have a look at how you've done. And hopefully you'll be bouncing up and down wherever you're sitting if you got it right. And if you didn't get it right, well, this is what Learn Extra is all about. It's so that you can learn a little bit extra and be a little bit more prepared for that final examination, which is coming up just around the corner. So let's get to that first challenge question. We had... if 2 sec theta is equal to 5 and theta is acute, calculate the value of that expression without a calculator. So our focal points are the fact that theta is acute, so therefore I can work in a right angle triangle. And we've also got the ratio 2 sec theta equals 5, which will help us in going a long way. So we would have sec theta equals to 5 over 2, which would automatically give us that cos theta is equal to 2/5, because we know that cos theta times sec theta equals 1, since they are reciprocal ratios. So it's much easier to work with a ratio that we often use with SOHCAHTOA. We often take sine, cos, and tan to find out angles. Much easier, that's what's on a calculator. So we try and reduce things into formats that we're more comfortable with, really. Right, so if theta is acute, we've been told that theta is acute. We now have that, this is the scenario. There's my theta, it's right angle triangle, and we've got that cos theta is equal to 2/5, and cos is adjacent over hypotenuse, which automatically helps us because we can now find out what the third length is without a calculator. We're not meant to find theta. You could have worked out what theta was just to compare your answers, but how would we find out this length in the right angle triangle? Yes, Pythagoras is always around to help us. The hypotenuse would be 25. This would be 4, so this would be the square root of 21. Okay, and that automatically means we've got what a third of root 21 over 5 squared is, plus cos theta, which we've also got from here, 2/5 squared. Okay, so sine is opposite. This is opposite over hypotenuse, and this one is adjacent over hypotenuse. So my opposite of theta is to root 21, and my hypotenuse is 5. So if I now just keep going, I get a third of 21 over 25 plus 4 over 25. So my common denominator is 3 times 25, so this one is just 21 plus 3 4s are 12. And we get 33 over 75. So without finding the angle, I've been able to find out what an expression is by utilizing the trig definitions from a right angle triangle from the SOHCAHTOA. So I'm wondering how many of you are really thrilled that you got 33 out of 75. That's good going. I'll do the second challenge question once we've looked at one of our trig contextual problems. Right, and the problem is as follows. Okay, this time we have a pilot. And the pilot, he's flying at 2,500 meters, and he reads the angle of depression of the top of a 60-meter building directly ahead of him as 22 degrees. So remember, all you're wanting to do is to get your bearings, to get the feel for what is going on here. Here's this pilot, he's flying, and ahead of him, he sees the top of a building. So he's flying on the horizontal, parallel to the ground, and we're making those assumptions here. And he then looks at the top of the building. So from the pilot's view, he's going to have to look down at the top of the building, so that creates that angle of depression. So remember, you're wanting to be able to capture this information in a different format, in a mathematical format that will assist you in solving for these unknowns. So just to give you a feel, here's the pilot. He's flying at 2,500 meters. He then sees the building, and there's the horizontal, and he looks down at the building. And they tell us that the angle of depression of the top of the building is 60 meters. Okay. So as a smart student, and this is not just in mathematics, but all across the other subjects, whether we're English or geography or any of the sciences, you need to always go back and read for meaning. You're not just reading just that there are words going through your head, but you're wanting to extract as much meaning as possible. So the first thing is the pilot's flying 2,500 meters. We are assuming that that pilot is flying parallel to the ground. And so we're making some assumptions here that this is vertical. Okay? There's a 60-meter building. So your automatic thinking is, well, if this plane had to fly across, how much would that be? Okay, so you begin to ask questions that would also extract some kind of meaning. Right, so we read again to make sure we've got all the information. A pilot flying at 2.5 reads the angle of depression of the top of a 60-meter building directly ahead of him as 22. So from the horizon, he's reading that as 22 degrees. Okay. And further than that, there's not much we can draw there. It just says, how far must he fly to reach a position directly above the building? So what is it actually saying? How far must we go, or how far must the pilot go, so that he reaches a position, so that he reaches that position? And let's call that position B. Okay? So we're really looking, how far is AB if we've got all this information? Well, we really do need our right-angled triangles. Without right-angled triangles, it's impossible to work out any lengths. So let's see if we can make up some right-angled triangles over here. We've got this position above the building, which is going to be a right angle. And we really do want to know how much this is. So I'm going to give these things some labels. AB, let's give this one C. So the building is CD, and AE is how far the pilot started off with at that position there. And obviously you're capturing, these are snapshots of just moments in time, because we can't capture the dynamic nature of this plane flying. So at that one position, this is what we see. We want to know what is happening once the plane has flown all the way to B. And can you see that, again, we've only got 22 degrees. Only one piece of information. How many pieces of information do we need with trig? We need 2. So we really do need to know how much that is. Well, that's not difficult to find, because the distance that the plane was flying, if he travels all the way across and he's not, we're assuming he's flying at 2.5 all the way, then this length over here is indeed just going to be 2.440. Okay, to give us that whole total of 2.550. So now this becomes quite interesting, because we now have this right-angled triangle over here, and we would like to find, if we position ourselves at this angle 22, that's my adjacent and that's my opposite, because this is my hypotenuse. So we would create the trig ratio that involves opposite and adjacent, which in this case is going to be our tan. So our tan of 22 degrees is going to equal our opposite, which is 2.440, divided by that AB that we're looking for. Right, by now we're professionals. We know how to find the denominator when we have the trig ratio and the denominator is the unknown. We've seen that all that happens is AB gets multiplied that side, and then we're dividing that by tan 22. So in the end, we can now use our calculator to just see what 2440 divided by 1022 is all about, that gives us a distance of 6,039 meters. So that's 6,039 meters. Okay, so we're saying that if the pilot flies 6,039 meters, he will now be at a position which is directly above that building of 60 meters. Okay. Now, there's a further question to this. There's a follow-up question. It then goes on to say, what is the angle of elevation of the aircraft? Okay, so these words are quite powerful because they tell us what we're looking at. So we are looking at the aircraft. Now, from where are we? From a point on the ground directly below his first position. So where's that? Where is the position on the ground which is directly below the pilot's first position? Do you know where that is? Let's go back to the picture. Okay. On the ground, the first position would have been at position E. And so we've now got that we're looking at the aircraft's new position. Its new position is at 6,039 meters. And so we would like to know what that angle is because we are elevating, so we are looking up. So that's angle E1. So what is that angle of elevation? And you see how you've translated that English into an actual model of what it looks like in mathematics. And that is what mathematicians do all the time. They take context and they try and adapt it into a mathematical context so that then they can use the mathematical tools to help them solve these problems. Right, so the pilot's first position was at A, position directly below him would be at E, and now we are looking at B and we're getting that angle of elevation. So we've now created this new right angle triangle. It's all about finding the correct right angle triangle. And building is at 90 degrees, and we would like to find out how much this angle is. Well, any suggestions? We've only got one piece of information. We've got that as 25. But the pilot has just flown 6,000. So if that was 6,039, that must be 6,039. Okay? So now we have two pieces of information. And with that, we can find angle E1, because if we at the angle E1, this length is opposite, this length is adjacent, so we can use the tan ratio. So we've got the tan of E1 would be equal to the opposite over the adjacent, and E1 is now going to be an angle that we are solving for. So on our calculator, we're going to have a button, a special button that finds us the angle, which is that tan to the minus 1. So we're going to first press the function, and then we need 2500 over 6039, and we just want to get out of that. And what is the angle? Well, 22,5. So it is almost the same as the angle of depression earlier, just half a degree. If somebody's looking up at the plane, they can actually see it at 22,5. And how many times haven't you been on the ground and looked up at a plane? So every time you've got a line of sight to the plane, that's actually your angle of elevation. So next time you look up at a plane, just ask yourself, how many degrees do I think that this angle of elevation is? But remember, somebody in the plane looking down at you will be asking a different question. They'll be asking, what is the angle of depression of the person on the ground, if they can see you, that is. Okay, so there's a nice question that involved both angle of depression and an angle of elevation. All right, I think it's time now to go back and do that second challenge question on solving that equation and see how many of you were actually able to get that angle A. Right, and And some of you are saying, but I've got angle A, I've checked my answer, I know it's correct, I would like another little challenge. So maybe we'll do one that we haven't done. And we'll check this question in a moment. We've got the shadow of a tower, 91 meters high, is 63 meters long. Calculate the angle of elevation of the sun. So I'll leave you to ponder on that one for a little while. You can get working. There's a tower 91 meters high. It casts a shadow of 63 meters. What is the angle of elevation of the sun? Okay? And while you're busy with that, the rest of us will be doing the challenge question, what is the value of A? Okay. Very interesting is that with this equation, we're sitting with that cosec, and we know that the calculator only has angle buttons for sine, cos, and tan. So our job is to, first of all, rewrite this equation in a different format, meaning the same, but in a different format. So we've got, first things first, and is that coefficient. We eliminate the coefficient, and we keep this angle as is, 2,486 divided by 2, which gives us a ratio of 1,243. Okay? Now we have a cosec ratio. Who is the reciprocal of cosec? It is sine. So if I take the reciprocal of cosec, which is sine, then I'm going to take the reciprocal on that side, which is 1 over 1,243. And that's how I get around my cosec, sec, and cot, is I use their reciprocal ratios by taking the reciprocal on the left and the reciprocal on the right. Once you've isolated the trig ratio, you're now ready to use the calculator. So we're wanting to know, it's a sine function, so it's sine to the minus 1, and it is 1 over 1.243, and that equals to 53,56. Okay, so 53,56. So therefore, our angle of 3A minus 42 degrees, what was it again? 53,56. 53,56. And we can now solve the equation 3A equals to 53,56 plus 42, and then we can solve for A by dividing that by 3, so it's 53,56 plus 42 divided by 3. And that gives us A. So let's see how many of you got that right. Let's just move that across. So we've got 53 plus our 42. And we're going to divide that by 3. So we get 31,9. And because there was no instruction, okay, you can then just write it off to one decimal place. So how many of you are jumping up and down that you got 31,9? How many of you checked your answer? It's very important with an equation to test the answer. So you would have come here and you have said 3 times 31 minus 42. You would have taken the cosec times 2 and you would have seen, did you get to 486? Because that's really the answer to the question. Okay, so we won't do that. We'll leave you that to do. Let's go back to the angle of elevation. See how many of you have been able to get that angle of elevation. What is the saying? The saying that if there's a tower and it's 91 meters high, it's going to be casting a shadow of 63 meters. And we're wanting to know what is the angle of elevation of the sun, which means we're looking up at the sun because the sun is casting a shadow on top of the tower. So we'd like to know what is this theta. And that theta really is the side that's opposite and the side that's adjacent, which is the tan ratio. So tan theta is equal to 91 over 63. And let's see what our friend, the calculator, says about that. So we've got tan of 91 over 63. And let's see what that angle of elevation of the sun is. And it was 55,3. So theta equals 55,3. Right, hope you all had fun. Bye.
Thank you, Dina. So guys, as you know, you went through a lot of trigonometric math today, and it's been absolutely awesome. Thank you for joining us. Thank you to Liberty again, and thank you to you Mindsetters for actually making the show. I know it's Monday and it's one of those days, but it's a warm day, and you guys joined us today, and we are grateful for that. There are still some prizes, so remember, you can still continue on the page while the grade 11s are on the show. See you guys. Bye.